I'm Carson Gardner, and this is my research done for artificial blood vessels. The system I chose to study was the coronary artery, which is located on the outside of the heart. And the parameters I found were using medical journals, and those journals said that the average adult male has a lumen diameter, which is the inside diameter, of 3.9 millimeters for a coronary artery, and an outside diameter of 5.4 millimeters. Also, the blood the normal blood flow rate was about 4.17 to the negative 6 cubic meters per second, and the internal pressures in that artery were found to be 16,000 pascals. The materials I chose to study in this paper were PFTE, PET, and Dacron, which is a polyester based tube. So PFTE and PET are the most commonly used material in these types of surgeries, and they've been using them for over 50 years. The good thing about these materials is that they're very cheap, and through numerous surgeries, they've been proven to work. Dacron, which is the polyester, is a stronger material that was just recently discovered and put into practice in these surgeries. And the catch is that it's significantly more expensive, being about $1 more per ounce than the other two options. So using these materials, we ran flow simulations on each of the lengths that we were going to measure, which were 1 millimeter, 10 millimeter, and 100 millimeter. Upon doing so, we found that the material had no effect on the pressures seen in the flow simulations, but what did change it was the length. So we did our readings for the normal blood pressure flow and 5 times the normal blood pressure flow to hit a worst case scenario. And these in the table show these pressures seen through these simulations. In each case, it saw that 100 millimeters experienced the most pressures, which is should be considered when picking a material for this surgery to be taken. Our static simulations were run for the 5 times blood pressure flow to see how they would react in worst case scenarios. So using the max pressures seen previously, we put those into our static simulation and measured the max strain, stress, and deflection, which can also be seen in the table to the right. When looking at the table, you can see that Dacron performed significantly better, being almost 10 times, seeing almost 10 times less deformation than PFT for a 1 millimeter vessel. And overall, it performs better than both of these other two materials. So using that information, I chose to go with Dacron for the artificial blood vessel replacement of a coronary artery. It performed almost 10 times better than the others, and it is a artery that's located on the heart, which is a very delicate and vital organ in the human body. So having that in mind, it is more expensive, but it is worth the money to have this system safely operating. Its ability to hold shape when under pressure is huge when working with the heart because it's constantly pumping and moving, and the pressures may build up where this strong material is going to be needed. So in order to safely recommend this to a patient about to go in for the surgery, I would say Dacron is the material you should use. And these are my sources. Thank you for listening, and if you have any questions, I'll be happy to answer them.